Good morning, students. Now, before we come to this, question number 9, this was question number 8 from the last time, and okay. So sector, we have already learned this right in the last class. If you haven't attended, you just check the online content. I think sir has uploaded it. All right. So sector, let me just repeat it again in order to make it more convenient for us to continue. If we take a circle and then we draw two radius, one here, another here, it's curved. So here, this shaded portion right here, this is called as the sector, right? This is called as the sector, the area, the portion that is enclosed by two radius. And we have to take into account this angle right here. This angle theta is called as what? Is called as sectorial angle. And we have got two types of sectors. One is the minor sector and one is the major one. And what differentiates the two? Which one is minor, which one is major? It is differentiated by this angle, sectorial angle theta. If the theta is less than 180 degree, 180 degree looks like this, right? This angle is 180 degree. If the sectorial angle is less than 180 degree, then we will call it as minor. If it is bigger, we will call it as major. And if I want to find out the area of the minor sector, let's say if I have a sector having an angle theta, the area is how much? The area is pi r square by 360 into theta. This is for this part right here. This is for the minor sector part here. How to find out the remaining part then? This is the minor segment, right? This is the minor segment. You can see that the angle theta is less than 180. So this is the minor segment. And the remaining portion right here, this remaining portion right here, let me shade it with a different color. This remaining portion right here, make it blue. This remaining portion right here, this is the major sector, right? Because if one angle is less than 180 degree, the other angle should be greater than 180 degree. So this is, the blue part is the major sector. For this part, how much was the area? The area was pi r square theta by 360. In order to find out the area of the major sector, what we have to do is, the whole area is how much? The whole area is pi r square, right? The area of this circle is pi r square. Out of this, you have to take this away. The green part is this one. If I want the blue part, if I want the area of the blue part, area of this one is for area of minor segment. If I want the area of the major segment, not segment, it is sector. If I want the area of sector, the total area is how much? The total area including the blue part and the green part, the total area is how much? Total area is pi r square, right? Where r is the radius. So out of this part is here, pi r square theta by 360. If I want the blue part, then out of the whole part, you have to cut off this part right here, isn't it? So cut off this part, you have to subtract them, you have to subtract pi r square theta by 360. I'm putting the theta and 360 together like this. Now, If you take common factor, pi r square can be taken as common factor. 1 is remaining in the first one. And what is remaining in the second term? From here, 1 is remaining. From this part right here, if pi r square is taken away, if this part is taken away, this part must be remaining, right? Theta by 360. So you have to put here theta by 360. And this is the area of the major sector. Minor sector is this part, pi r square theta by 360. You can put theta and 360 together. I can remove this. And you can put theta by 360, right? Same thing, right? Denominator, you can put it below pi r square or below theta. And for the major sector, you have to subtract it from pi r square. This part right here, you have to subtract it from pi r square. And this is the area of major sector. Area of minor sector is here, area of major sector is here. We have already done some calculations that is related to area of minor sector. So I want you all to copy this. Take some time, copy this, okay? Copy this and this. You have to draw the figure also. And if you have a red pen, set it, don't set this as red. Moving on, let me rub this off. So I have given a little introduction on what is a segment previously. You know what a sector is, it's very easy. But what about a segment? What is a segment? Let's say you draw a chord, the red line, this is a chord. This is a chord. The portion that is right here, this is called as segment. Okay, let me remove this first. When you draw a chord, this chord divides the circle into two parts. One portion above, one portion below. These portions, they are known as segment. So actually here, this smaller portion right here, this will be called as minor segment. And this portion, the bigger portion, white portion, we will call it as major segment. Okay, your calculation, it will concern with what is the area of the segment. And mostly we are going to focus on the minor segment. All right. So minor segment, let me just set it. Let me set it with green. This portion right here, this is the minor segment. Minor segment right here. How to find out the area of a minor segment? When we ask that question, how to find out the area of a minor segment, let me draw it a little differently. Let's make the sector a little bit bigger. And we draw the chord like this. This doesn't look very good. And we will draw a chord right here. So this line right here is the chord. And this whole portion right here, what is this called? This is called as sector, right? And what are these? These are the radius. So in plural, we will call them as radii, or radi, whatever your pronunciation is. Okay, O, A, B. Where is the segment portion? Segment portion is actually right here. This part is the segment portion. Hello. Who's turned on the microphone? So this part is the segment. If I want to calculate the area of the minor segment, what we are going to do? What we are going to do is simple. We know area of this portion. This is a sector, right? This whole thing is a sector. If we know this angle theta, then the area of sector will be how much? Pi r square theta by 360. But we don't want the whole thing, isn't it? We don't want the whole thing because we want this only green shaded portion right here. So out of the whole thing, if I cut off this portion right here, if I cut off this portion right here, then what we are going to get is we are going to get the green portion area of the segment, right? So to find out the area of a segment, we will find out the area of sector first, this whole portion first. We will find out the area of this triangle portion then, and then we will subtract the two. That way we are going to get the value of the minor segment. So let's say I want area of segment. Area of segment is the green shaded portion, right? So for that, the area of segment will be given by area of sector. Let's say this angle is theta minus. What will we subtract from this whole portion? This is the area of sector, what I'm writing right here. And we have to subtract this white part. White part is what? AOT. From the area of sector, we are going to subtract area of triangle. What's the name of the triangle? OAD. Area of sector, do we know? Yes, we do. Do we know the area of the sector? So area of sector will be how much? The area of sector is pi r square theta by 360. We have already done this. Minus. What about area of triangle OAD? The area of triangle OAD, let me draw it on the side. Here is OAD. OAD. How much is this angle? This angle is theta. How to find out the area of a triangle? You know that area of a triangle is half into base into altitude. If I take this as base, if I take OA as base, then we have to draw an altitude. Altitude will be perpendicular. It will look like this. So let me draw the perpendicular line. Let me draw it with red. And let's name it as C. So if you look at this triangle right here, if you look at this triangle portion right here, COD. If one angle is 90 degree, then this is a right angle triangle. What we want is this portion right here, this CD. So in order to find out area of triangle, we need half base into altitude. What is the base right here? This is the base. So OA is the base. Now we can write half into OA into. What about the altitude part? Altitude part is right here, this part right here. This DC is the altitude part. So altitude is DC. Do we know OA? Yes, we do. We know OA. OA is the radius itself. This triangle I'm redrawing right here, okay? This OA is the radius, so I can put OA as what? I can put OA as R. What about the DC part? What about this DC part? Okay, look, with respect to this angle theta, this is the opposite side. Right, remember trigonometry a little. When you look at this triangle, this is a right angle triangle, this is 90 degree. And if you take this angle, this side is the opposite side. If I divide opposite side and the hypotenuse, what do we get? We get the sine theta, right? So if I find out sine theta here somewhere, sine theta is how much? Opposite by adjacent, opposite by hypotenuse. Opposite is this part right here, CD. Hypotenuse is what part? Hypotenuse is OD. Opposite to 90 degree, that's the hypotenuse. So CD divided by OD. We wanted CD, right? Cross multiply. CD is equal to OD sine theta. What is OD again? Think. OD. Here, what is OD? OD is again radius, right? So I can put the value of OD as R. Okay, look, when we find out CD sine theta, it is CD divided by OD. Which triangle? This triangle. And by putting OD as R, the value of CD is how much? R sine theta. So CD or DC, whatever it is, DC I can put it as R sine theta. So half it will remain as it is. R and R is how much? R into R is R square, right? Half R square sine theta. Now look, when I want to find out the area of this triangle, after so much many efforts, we have found out that this area of this triangle OED is how much? Half R square sine theta. So here I can replace here area of triangle OAD. Area of triangle OAD is how much? Half R square sine theta. So just put here half R square sine theta. We wanted to find out this portion. Remember what our goal is. We wanted to find out the area of segment. In order to do that, we first find out the area of sector, that's pi r square theta by 360. And then we are trying to cut off this portion right here, OAD. So for this portion, the area is how much? Half r square sine theta. Now, whatever the common factor is, you can take it out. R square is present on both 2 and 360. From 360, we can take out 2 common factor, right? So take out R square by 2 common factor. What is remaining? Here pi is remaining. R square is already outside, right? That means theta must be remaining. Who is turning on their microphone suddenly? And out of 360, 2 is taken away. If 2 is taken away out of 360, how much is remaining? 180, right? Minus. Half is taken away. R square is taken away. That means sine theta must be remaining. So this right here is the area of a segment. Area of segment is R square by theta, R square by 2, pi theta by 180 minus sine theta. All right. Okay, so you copy this. You have to draw both figures. And you have to copy this on the side also. Okay, then moving on. So let's take up question number 9. This question has questions related to sector, and there is questions related to minor segment also. We are not going to calculate this major segment because for major segment, we will take up how to find out the major segment from the other questions. Let's see what the question gives. All right. In a circle of radius 6.3, we're given a circle. We're given a circle, right? How much is the radius? The radius is 6.3. Radius is 6.3 centimeter. Then an arc AB subtends an angle of 90 degree at the center of. You take an arc here, arc is a portion of the circumference. So the question gives a name of the arc. This portion of the circumference AB subtends means if you join it with the center like this. You join it with the center, the ends of the arc, if you join it with the center, the central angle is given. Central angle is given how much? 90 degree. Subtends an angle of 90 degree. All right. So the center one is 90 degree. Question one, what? Question one, find the length of the arc AB. How much is the length of this arc AB? Area of the sector AOB. So the center one is O. Question one is the area of this portion right here. Area of the sector. Then perimeter of the sector. Let's come to the segment question later on. Okay, we will take it out from the uh, other other question. The calculations related to segment, we will take it out from the other questions. Let's just calculate the portions for the sector. All right. Length of arc AB. We want to find out this. Area of the sector AOB. Area of this portion right here. And perimeter of the sector AB. AOB. The perimeter is this part, and this part. The total is perimeter. So, first of all, let's start the solution. What is given? Radius is how much? 6.3 centimeter. Sectorial angle is given 90 degree. Question one's length of the arc. I have already given the length of the arc. Length of the arc is twice pi r by 360 into theta. That is the length of the arc. I've already given, right? So twice pi r by 360 into theta. We cancel 2 and 360, we get 180 here. So we get pi r theta by 180. This is the length of the arc. So if I want to calculate the Roman number 1, we will say length of arc is what? Let's say it is represented by L. L is pi r theta by 180. You put in the value. Pi is 22 by 7. R is 6.3. Theta is 90 degree. And we will have 180 here. So very simple. 22 by 7. R is how much? Radius is 6.3. Theta is 90 and 180 here. Okay, you listen carefully before copying. All right. And I can cancel out 90 and 180. Right. 92 is 180. 2 and 22 you can cancel out again. 2 11s are. 7 and 6.3 you can cancel out. Look. 63 by 10. This is 6.3. You can cancel it by 7. 7 9s are. What is remaining here? 9 by 10 part is remaining, right? 9 by 10 will be how much? 0.9. So you can say if there is 6.3 right here, you can cancel 7 and 6.3. 7 9s are 63. But you have to have a decimal point in the front, 0.9. No denominator is left, right? 7, 180, all of them are cancelled out. And what is remaining? 11 and 0.9 is remaining. So we will write 11 into 0.9. If you multiply, it's 99. 11 9s are 99. One decimal point, so we will put one decimal point in between. Right. So Roman number 1 is done. Length of the arc AB. It's found out now. Now Roman number 2. Look, area of the sector AO. Area of sector, we have done it many times. If you refer to the previous class, you will be seeing abundant questions. And Roman number 2, It will be how much? Area of sector, what's the formula? Area of sector, I just told you, pi r square theta by 360. So you put in the value, pi is 22 by 7, r is 6.3 into 6.3. Because there is r square, you have to put it 2 times. Theta is how much? Theta is 90. And there is 360 down below. Okay, time to do some cancellation. 94 is 360. 2 2s are 4. 2 11s are 7 and 6.3. You can cancel that further. 0.9. What is left? As numerator, we are left with 11, 0.9, and 6.3. What is left as denominator? 2. On further multiplication, we will obtain 9.9 and 6.3. Look, if you multiply 11 and 0.9, we have just seen that we obtain 9.9, right? 9.9 and 6.3 you multiply in the side. 6.3 and 9.9 multiply, 9 3s are 27, 9 6 are 54, 54, 56. So 5, 6, 7 again. 7, 3, 2, 6. 2 decimal points. So we will have 62.37 divided by 2. You can divide this and then you obtain, you can divide this by 2 and then you can obtain 2 3s are 6, 2 1s are 2, 2 1s are 2, 2 9s are 18. So once you know the area of the sector, the rest is just multiplication and division. Okay, so pi you put 22 by 7, r it's 6.3, and theta is 90 degree, right? As given by the question. All right, then copy this. We will come to Roman number 3 later on.
Sir, done.
Really?
Sir,
Really, you all are done?
no, sir.
One said yes, one said no. Which one should I take?
No,
I have to
sir.
wait for. Okay, then. Tell me when it's finished. All right. I am taking off the Roman number 4. I'm going to show you how to find out the area of minor segment and major segment in other question. Okay, coming to Roman number 3. Let me rub this off. Coming to Roman number 3. Roman number 3, I have to find out the perimeter of the sector area. So how to find out the perimeter of the sector? Perimeter of the sector is the length of the surrounding portion. So this surrounding portion, it has 3 parts, right? We have got OA right here. We have got OB right here. These are the radius. This is radius. This is also radius. What is this part? This part is the arc, right? How much was the arc? Arc, we have got 9.9 already. Radius is 6.3. Radius is 6.3. So this OB portion is 6.3. This OA portion is also 6.3. And this AB portion right here, this is 9.9. We have already calculated the length of the arc, right? Length of arc we have already calculated and found it to be 9.9. So coming to Roman number 3, if you want to calculate the perimeter of the sector, there's got three parts: OA, OB, and AB. I'm writing AB with a curved portion right here. This indicates that this is the arc AB. All right. So OA, it's the radius. It's R. OA is 6.3. OB is 6.3 because both of them, it represents the radius. Arc AB is how much? 9.9. You add them 6.3, 6.3, 9.9. 3 to 6, 6 and 9, it's 5. 1 carry. 6, 6, 12, 21, and it's 22. So final value will be how much? 22.5 centimeter. Right. Copy this. Roman number 4. Let's keep this. We're going to take it up. Don't try to remember and don't just try to copy. I want you all to understand the concept. What is the next number coming from? What will be the next step? How to find out this, how to find out that. So here comes a question related to segment. It still asks the how to find out. It still asks to find out the area of the sector. Okay, look, the question is saying a chord of a circle of radius 12 centimeter, subtends. You have to understand the meaning of this word subtends. If we have a circle and we have a chord or an arc, if you join the ends, of the chord with the center, then this angle right here is called as angle subtended. Okay. If you don't have a chord, if you have an arc, if you have a part of a circle, and if you join them with the center of the circle, this angle right here is called as angle subtended by this arc. Right. So a chord of a circle of radius 12 centimeter, the radius is given according to the question. Radius is 12 centimeter. It's given. Subtends a right angle at the center. So at the center, how much is the angle subtended? It's a right angle. That means it's 90 degrees. Question 1, find the area of the corresponding major sector. Major sector. Area of major sector. This is the first one, and second one is minor segment. All right, then. Look, we have got the circle and we have got a chord. And how much is the radius according to the question? Radius is 12 centimeter. How much is the angle subtended at the center? It's 90 degrees. What is the question 1? Question 1 is the major sector area, minor sector. So minor segment is this part right here. This is the minor segment. And what is the major sector? This is the minor sector. This is the minor sector. That means the remaining part, this remaining part right here, this must be the major sector, right? This is the major sector, isn't it? So if this angle is 90 degree, how much is the remaining angle? If we have this angle, this is 360 degree. Out of the 360, if you remove 90, out of 360, if you remove 90, how much is it? 270 degree, right? So this portion right here, this angle is, this angle is how much? 270 degree. So if you want the major sector part, the angle is 270, the radius is 12. You just find out the area that way. Okay. So start the solution. How much is the radius? Radius is 12 centimeter. Angle theta or the sectorial angle is 90 degree. This is for the minor sector. This is for minor sector. So you mention here minor sector. So for major sector, let's say it's theta prime. This angle is for the major sector, right? This small angle is for the minor sector. This big angle is for the major sector. So for the major sector, the angle is 360, you subtract 90. 360 minus 90 will be 270 degree. Okay, then find out the area of sector. Area of major sector. What's the formula? Pi r square theta by 360. Pi is 22 by 7. R is given as 12 into 12. And theta is how much? 270 divided by 360. Why didn't we take 90 degree? Because if you want to take this portion, this is the minor sector, we will take this angle 90 degree. Question one's for the major sector. All right. That means you have to take this whole thing. You have to take the whole portion, and this angle will be how much? 270. Where did the 270 came from? The total is 360 degree. If you take away 90, the remaining is how much? 270. Okay, time to do cancellation. 0 and 0. 9 3s are 27. 9 4s are 12. And 9 4s are 36. 4 3s are 12. What is remaining there? 22 into 9. 12 into 9 divided by 7. 22 is right here. 12 is right here. If you multiply these 3 and 3 written in red, 3 3s is 9. Okay, multiply. 12 9s are 108 and 216. 6 7 3 2. So 2376 divided by 7. I multiply this numerator portion, we get 2376. And then you divide this by 7. 7 3s are 21. 7 3s are 21 again. 7 9s are 63. 7 4s are 28. So we will put 339.4 centimeters square. Since the radius is given in centimeter, the area will be in centimeter square. Okay, the second part, it's going to be slightly long. So copy up to here first. And I'm rubbing off this portion also. So now it's time for us to find out the area of this minor segment right here, this portion. Right, the shaded portion shaded in green. Find it out. And we just did the area of a minor segment, right? Area of minor segment. What was it? We have got something like this, r square by 2. Pi theta by 180 minus sine theta. So it's simple, right? You just have to put in the values. R is 12, 12 into 12 divided by 2. Pi theta by 180. Pi, the question says use pi equal to 3.14, right? So you use 3.14 and theta will be how much? Theta is 90 degree as given. 180 degree minus sine 90. So we just replace the value of r and theta, that's it. So r is replaced as 12 and theta is being replaced as 90. That's it. So 90 and 180, we can cancel it out. Whatever is inside the bracket, let's take care of it first. This and this we can cancel. We have got 2 here. And I can cancel the outside also. 2 12 are 6. So how much is it? Numerator, we have got 6 remaining and 12 remaining outside. And what about this part right here? 3.14 is being divided by 2. 2 divides 3.14. How much is it? 2 ones are 2. 2 fives are 10. 2 sevens are 14. Right. So 1.57. I can put here 1.57 minus sine 90. As you all know, sine 90 is 1. You can look up the trigonometric table. Sine 90 is how much? Each 1. So you put 1 here. 6 into 12 is 72. 1.57. From there, you subtract 1. So we have got 0.57. Okay. You multiply these two, how much you get, you check it out. Let's just check it here. Multiply this with 72. 2 sevens are 14. 2 fives are 10. 11. 7 sevens are 49. 7 fives are 35. So 4014. 2 decimals. So we have got 41.04. We are finding out area. So it's also simple. Just you need to understand the formula. You need to know the formula. And you have to understand where this is coming from. It's not asked in the your board exam. I mean, how does the how does the this formula come into being? But I have just shown you before, right? In the beginning, I have shown you how we are able to obtain this formula. Okay, so copy this. Let's end the class here after copying this. Copy up to here. So area of minor segment, the formula is this. You just put in the value of r and theta.